Hello. All right. Thanks. Thanks for bearing with me. I think we're all good to go, powered up here. Trek, thanks for the intro. For someone who is always complaining about handcrafted web frameworks, I really appreciate your artisanal handcrafted introduction. Thank you. So for those of you who don't know me, I'm Dan. I do a fair bit of open source. I work on Ember, Orbit.js, which is a data access and synchronization library, and the JSON API spec. If you'd like a hand with any of these technologies, I consult through Cerebris, the company I co-founded. So let's talk about worker power. This really is a talk about the power of organized labor. The ability of workers to take on bigger challenges together than they could on their own. This holds true not just for people, but also workers in your browser, also known as web workers. And they come in several varieties: dedicated workers, shared workers, and service workers. I'll get into the differences soon, but first, why should we care about workers at all? By default on the web, all processing happens in what's known as the main thread. The main thread is responsible for everything: fetching, parsing, running JS, page layout, paint, observing user interactions, manipulating the DOM. It does all this processing concurrently. Workers are the only threading primitive available on the web. Workers allow you to offload processing to different threads, which run in parallel to the main thread. You can set up communication channels between the main thread and workers, and even workers with other workers, and offload that processing, which is now occurring in parallel. Rob Pike, the creator of the Go language, said, "Concurrency is about dealing with lots of things at once. Parallelism is about doing lots of things at once." And web workers represent the only path to parallelism for web applications. Joe Armstrong, the creator of Erlang, made this analogy, which is quite appropriate for a developer conference. Concurrency involves managing multiple queues that access a single coffee machine, while parallelism gives each queue their own coffee machine. What happens when we exceed the limits of concurrency on the main thread? Or what happens when those customers have to wait too long for their coffee? They're going to get cranky, and so will the users of our web apps if they experience something called jank. Much like obscenity, the definition of jank is a bit subjective, but you know it when you experience it. Most sighted individuals experience something being a bit off when animations drop below 60 frames per second. This means that browsers need to repaint every 15 milliseconds, or else the experience will start to feel janky. It's easy to imagine that, for all but the most extreme cases, this has now become a hardware problem. State-of-the-art smartphones are getting undeniably faster. Those new iPhone 11s won't have a problem scrolling your list view, so why should you care? Even though the high end continues to improve by leaps and bounds, the online population will only continue to grow in the decades to come. And it will grow disproportionately in places where new users can only afford low-end, cheap phones. So the median online experience will likely move towards lower and lower-end, cheap smartphones. And the latest devices from Cupertino won't offset this trend significantly. Last year, Tom Dale spoke at this conference about his vision for the future of Ember, to make it easier to build apps that work around the world. In other words, we want to focus on providing the best user experience possible, regardless of who our users are or where they're from. During his talk, Tom also revealed the core team secret that all of Ember's performance improvements were inspired by a 2001 version of Real Player. Seriously. And as an aside, surely there's no coincidence that Apple just released their music player written in Ember a year after this talk. Anyway, I'd like to focus briefly on this list of enhancements, all of which deliver less code, faster, more on demand, and improve time to first paint and time to first interactivity. And I'd like to add another technique to this list that's broadly used by native apps, multi-threading. Multi-threading allows apps to use parallelism to improve performance. And the way to achieve multi-threading on the web is through workers. Hopefully, by now, you're excited to try out web workers in your own applications. But you're probably simultaneously wondering why workers aren't already being used more often. Perhaps there are some technical hurdles that are insurmountable in the short term. Web workers actually aren't a new and unproven technology. They've been around since 2012, and they're widely supported in browsers, at least the base form, the dedicated worker. Perhaps workers don't give you enough capabilities. Actually, they provide pretty much full access to the browser's APIs, except for manipulation of the DOM. Actual challenges that I've found using workers are that they're a bit awkward to use. They're a bit awkward to test. And frankly, there's a lack of front-end framework support for them. I'm really optimistic about this because these are all developer experience problems. And as developers, we have the ability to improve those experiences. So before we get into the different types of workers, let's review some of the characteristics that they all share. Because they operate in a separate thread, communication between them, between each other, and between the main thread has to be async. And there simply can't be any shared memory. You can't share objects or functions that are manipulating the same memory space. They all have a controlled lifetime, and as you'll see, there are different ways to control that lifetime, but you do have control over it as a developer. And as I mentioned, they have access to pretty much full extent of the browser APIs. You can issue fetch from a worker. You can access IndexedDB from a worker. You can do pretty much everything except access the DOM. That's left to the main thread. And really, ideally, that would be the bulk of what happens on the main thread, is accessing the DOM. So let's get into the most basic, earliest supported type of worker, the dedicated worker, which actually has global support in the high 90%, supported on all the major browsers, even IE and Edge. So this is very promising. This is an example of application code on the top, which is which is communicating with a worker on the bottom. And the worker is simply multiplying two numbers together. So let's walk through this a little bit. The first step is that the application has to spawn the worker. And it does that with a URL to the worker's JavaScript file. So the worker started, and you can immediately send messages to it. Notice we're sending an array here, and that is received by an event handler in the worker code itself. And it can be accessed. You can access the data that was sent to it, the array, and we're accessing both the first and second element, multiplying them together, and then posting a message back to the main app. And that is then received in this event handler, this onMessage handler, and the result is logged out. For something fairly simple here, there's a bit of a song and dance, but it's pretty understandable. So let's step into the worker class a little bit. Workers are spawned, as I said, with a URL. And there are some options that can be passed to the worker, such as the type. You actually, in the spec, the worker spec, you actually can support modules, ES modules, inside your worker code. And it will, it will walk through those dependencies. But it's not really fully supported in Firefox. And so that's a bit of a paper cut, but we'll get through that. Also, sorry, that's the, it helps with this wall of text if I underline it, I think. So that's one option. You can also send credentials to the worker and a name for debugging. Now, the post message code, how you communicate with workers and how workers communicate with other workers or the thread, the main thread. So they can send a message. Now, the message can't be just anything. It has to be clonable. There's a structured clone algorithm inside the browsers which will clone any arguments passed to the worker and then send the clone so that the clone is given to the worker to deal with. And so so that they're not actually sharing memory, it's copying that memory, and the worker is dealing with the clone. So you can't pass functions. You can't share objects by reference. And there are actually some more advanced transfer options too, which allow you to pass control of an object. Again, you can't share the same object, but you can basically perform a handoff of an object to the worker, and it takes control of that memory. And after you've done this, then the main thread can't access it further. And workers can be terminated, and that the terminate command will free up that thread and stop whatever processing is happening. Okay, so let's get away from the MDN docs a bit and look at a demo. So this is a little calculator app. I retrofitted the To-Do app, To-Do MVC app for this purpose. I guess it's sort of a reverse Polish notation calculator. But anyway, let's walk through what happens here. So it allows you to enter numbers, it sums them up, and that's all pretty straightforward. Now, I've added the ability to add some extra processing, which basically performs a Fibonacci sequence based upon the sum. So whatever that's the sum total there is, that's the length of the Fibonacci sequence. That's Oh, well, that's interesting. That's actually a pretty perfect place for my talk to get janky. I don't know. Let's see, how did this happen? Oh, maybe I bumped it. Sorry. Okay. All right. There we go. Good. Thank you. Yeah. So yes, everything just went on the blitz there. The main thread's overloaded. Okay. So now I've added another option here. This is the same app. We're going to enter the exact same numbers, except we're going to be performing that extra work, that Fibonacci sequence, on the worker, on a worker thread. And I'm going to enter the same numbers here, the same process is happening, but you can see I enter that massive number. We're still flying along here. So it is not slowing down the user experience. There's no jank, even though that worker thread is working hard. And you can see it's still figuring out that Fibonacci sequence, and it's got a queue backed up there, and it may take a little while for it to finish. But the important thing is that that's not affecting the interactivity of your app, and it's about as good as you could hope for when you're doing something so expensive. All right, so we talked about dedicated workers. Now let's talk about shared workers. Shared workers aren't supported quite as broadly as dedicated workers. They are not yet supported on Safari or Edge. They're never supported in IE, and I suppose there won't be support in Edge until it goes to Chromium. So there's only about high 30%, 36% global browser availability here, but it's a really cool feature. It allows you, shared workers, as the name implies, allows you to share a single worker across multiple threads, including other workers and or multiple tabs in the same browser. So how do you use them? It's very similar to the dedicated worker. We're spawning the worker with the shared worker class instead of the plain worker class. And that references, again, the URL of the worker. This is an incrementer this time instead of the multiplier, because it's going to share a little state, this integer, the I equals 0, and at first, and we're going to just, every time we post a message to it, we're going to increment that. So first, before we do that, we have to actually start up the worker. We have to start up a port to this shared worker. So we'll do shared worker.port.start. That's how we start this life cycle on this main thread. And we can also close that port later whenever we want to terminate that life cycle. So then when we send a message, we're going to receive that in the worker's onMessage handler, and we're going to return an incremented version of I. And that's going to be posted back to the main thread, and it's going to be received and logged out again. So this introduces a new interface, the message port interface, which supports post message and then start and close for managing the life cycle of this port. Now here's a demo I'm pretty excited about. It actually uses the exact same app, but it uses a shared worker behind the scenes. And I've got two different browsers, two different tabs, it doesn't matter, open, viewing the exact same app on the same URL. So let's see what happens. I'll explain what's going on behind the scenes, but I'll walk through this. So we're going to use the same calculator, but as you can see, all the data is kept in sync, and it's done on the shared worker. We can change the UI of each, and the reactivity will work. Where it's not a complete duplication. What's being shared is the data. Each window has its own store, but they're communicating with shared memory on the shared worker. And that's being done with Orbit.js, which is loaded into the shared worker and can access IndexedDB. It could also coordinate an offline strategy so that it's connecting with fetch to a remote server. It could warm the caches of these stores in the main threads. You have a lot of flexibility here. We're just showing a simple synchronization, but this is solving some of the harder challenges of web applications when you have to worry about things getting out of sync and different. Say you're offline. This will still work because you're not relying on WebSockets to keep you in sync. You're actually doing it locally, and you're also using less memory too. And you're doing this off the main thread, so that you're having a more optimistic experience as a user. So altogether, it's a better user experience, and it's making the most of the shared workers, I think. Okay, so the third kind of workers that I'd like to cover today are service workers, which kind of are workers that have superpowers. These are probably the workers that you're most familiar with, actually, because there has been a lot of talk about them for providing complete offline experiences in the last few years. Service workers are pretty well supported. It's also in the 90s and across most of the major browsers except IE. There is so much to service workers that I don't think I have the time to go into them fully today, but I will give a brief overview. I gave a talk about them at JSConf Iceland. I have the link here. I'll provide that later if you want to dig a little deeper into them. Basically, these are I'm going to show a few slides from that talk and then move on. So. Service workers are one of the key ingredients for progressive web apps. Progressive web apps have a long checklist of items, which you can go through by checking your Lighthouse and your dev tools. So the site needs to be served over HTTPS. Pages are responsive. It works offline. The app's URLs work offline. Has add to home screen. Fast first load because some assets are cached, and more. Service workers are a special kind of worker that acts as a proxy between your application and its environment. So you can register your service workers, and you can listen to different events. In the same way that we were listening to messaging, just general messaging events, you can listen to load events, you can register your worker, you can describe what assets you want to cache locally in your browser, and then these will be served up if your user's offline to provide a snappy experience. And you can even customize the responses to fetch so that you cache certain results. So there's a lot to service workers, and there's a lot to progressive web apps. I think we'd be going in the weeds a little too much and pushing lunch back even further if we went any more into this. So let's try to wrap up with a few. Having reviewed workers and their interfaces, let's see what we can do to improve the developer experience. There's an add-on I'm working on, Ember Workers, which is behind all of the demos I gave today. The secret sauce is that it uses Rollup.js to look in your workers directory, which is a new directory that this add-on recognizes, and it compiles your worker into into your assets. It doesn't just compile the worker code, it also walks the dependency tree and concatenates everything so that you have all of those dependencies wrapped up into a single script. And you can then access that without worrying about your browser's support for ES modules in Workers. Like I said, Firefox isn't quite there yet. So this makes Workers accessible everywhere. Rollup also does tree shaking, and this is also a huge opportunity for Embroider too, which Ed is going to go a lot deeper into build topics, and we've been talking also about incorporating support like this for Workers in Embroider. All the capabilities are there already, so it's just a matter of time to use your Rollup or your favorite final stage packager to bundle up your worker code, and that'll be coming to Embroider too, I think. Okay, so another paper cut for the developer when dealing with Workers is that they are evented, and the evented async can get a little awkward. You have to set up listeners, you have to send messages and post messages back and forth. Nolan Lawson came up with an add-on general NPM package, which is Promise Workers, which you can use in your worker code. And basically, all it does is wrap that evented code there in Promisified code. So you can use async await, send messages, get results, and it's a more pleasant experience. And perhaps the biggest challenge to using Workers in a robust application is testing them. So I have a few tips. It's a big topic in and of itself. First thing is to make your Workers as modular as possible. Unit test those modules without Workers. And then, because of course your app relies on those Workers, a good approach is to stub those Workers in your tests. Friend of the community, Trent Willis, who also worked on Ember engines, he's put out a package called WorkerBox, and WorkerBox actually helps you with that stubbing in your apps. It overrides the worker class for tests with your own custom worker class, and you can provide implementations for stubbing in results for your tests. So it's a pretty nice experience. If you want to hear more from Trent talking about Workers and WorkerBox, I recommend this talk he gave a few months ago. So that's all I have for today. Please, we can't take questions now, but please feel free to ask questions at lunch or in the hall whenever you see me, or online at DGEB. I've prepared basically a blank canvas where I will fill in all my resources that I use to prepare this talk, and also provide those links to the add-ons. And so if you want, I'll be posting those updating that in the next few days and tweeting about it. So anyway, I hope you're all as excited about using Workers as I am. Thanks.